Okay, so as a start off, there are terms that I think are very important for us to understand, especially in probability, so that we are able to interpret questions, scenarios, and any type of contextual um, question correctly to be able to interpret it correctly. So the first one says probability, and basically what that means is that it's the chance that something will happen, right? And basically probability is what we're looking at. It's the context focusing on probability. And so probability is basically the chance that something will happen. And then we talk about prediction. And now prediction is saying what might happen in the future. And prediction, you can also think of it as maybe an approximation of the future, right? It's an approximation of the future. It's thinking in the future, but not knowing what the actual value of the future would be, or the actual thing that will happen in the future, but to see it before it happening, or having a number to measure how probable, and probable meaning that how much chance it has of occurring, right? And then when we look at an event, basically an event occurs in uh, is what occurs in order to produce a result or outcome, right? So an event is one of the things that happens to produce that result or outcome, right? And then when we talk about an outcome, is the result of an outcome, right? And basically an outcome is a result of the outcome. Sounds confusing, but that's what it is. And then we have the probability scale. So, the probability scale is actually quite important, especially when we're talking about context, focusing on probability, because if you understand the probability scale, you are able to tell quite well whether or not something is likely or unlikely to occur, right? So basically, a probability scale, a definition for it is that it's a way to measure how likely or unlikely an outcome will be, right? And then we have a very important term, which we call the relative frequency. Now, the relative frequency, we usually find it from a particular trial or outcomes, right? So basically, if you look at it, it says relative frequency is the number of times an outcome, right, occurs divided by the total number of events that happened. So basically, thinking about it, if we had like a coin and we toss the coin 5 times, and in that 5 times, the coin lands on heads 3 times. When we say it's an outcome, we are talking about the three heads um, that came out of it, because you have two different outcomes. You either have heads or tail, but then it is an outcome, so you have three heads, right? And that's an outcome, and then it's divided by the total number of events. But now, the total number of events, how many times did we toss the coin? 5 times. So it would be 3 over 5, and that would be a relative frequency. And then we have the theoretical probability. Now, the expected probability of an outcome based on what we know about the event and its possible outcomes. Now, the theoretical probability is more given to you, it's more expected. You have a good understanding that it should be, you can expect the probability to be 1 over 2, right? For instance, when you tossing a coin, right? And then we have the tree diagram, and the tree diagram is basically a diagram that shows all the possible combinations from uh, from from more than one event, right? And basically, that is a tree diagram. So now let's get into some questions that have to do with this, right? Now, again, as I said before, it's quite important to understand the probability scale, right? And basically, here it says Say whether the following events are likely, unlikely, equally likely, or and unlikely, almost never, or very likely to happen, right? So we have A, B, C, and D. And with A, now remember, since you're doing mathematical literacy, it basically means that you need to think in a contextual manner, right? And these questions are contextual in a way, if you think about it. If it says we have a 90% chance of rain tomorrow, it literally means that you can expect that by the time you wake up tomorrow, the clouds will be formed, and those clouds will be formed and it will rain. And especially if you can actually even see it, you actually can have a feeling that, okay, maybe tomorrow it will rain quite heavily when it's 90%. So, therefore, it is very unlikely, right? So, a 90% chance of rain tomorrow. This should be very likely. Sorry. Yeah, this should be very likely. And then a tsunami in Johannesburg. That's almost never. That is extremely unlikely. For the simple fact that we all know that Johannesburg is in a it's an inland. It's an inland and it's very far away from any ocean. And either way, if you're doing geography, you'd know that we do not have any tectonic plates that move near the Johannesburg or South Africa. In actual fact, so even in Durban, there wouldn't be a tsunami. So that's almost never. Okay, and then C, it says turning into a frog. Now this one is definitely a never. It's just definitely a never, because if you think about it, that would imply that magic exists, and we all know that magic doesn't exist. Yes. And then D, it says throwing a dice and having it land on an even number. Right. So you are throwing a dice and having it land on an even number, right? So it's equally likely, meaning that whenever you're throwing the dice, it is equally likely to get any particular outcome, and it's landing on an even number. How many even numbers are in a dice? Thinking about it, remember, it's 1, 2, 3, 4, 5, 6, right? And the only even numbers is 2, 4, and 6. Out of 6 numbers, that would mean it would be 1, 2, 3, 3 over 6, which is almost half, so it's unlikely, right? And then throwing a dice and having it land on 1, and that's something that is quite unlikely, right? Throwing a dice and landing on 1, definitely unlikely. Okay, so we go on to the next question, and the next question here says, for each of these events, give the theoretical probability that the outcome given will occur. So this is a theoretical probability. This is the one that you think about. You don't need to really look into an experiment that happened, but it's a theoretical probability. So it is A, throwing a dice and having it land on 2. So 2 is a single outcome within 6 different, yeah, uh, um, it's a result. It's six, 2 is a single result in 6 different outcomes. Yes, so it's 1/6. And throwing a dice as well, and having it land on an even number. There's 3 even numbers, so it's 3/6. And 3/6 you can actually write as 1/2, right? And that is just a half. And also C, throwing a dice and having it land on 7, right? Throwing a dice and having it land on 7. But the problem is a dice only has 6 sides. So it's actually 0/6, which is just 0, right? So that is not likely to happen. And then flipping a coin and having it land on heads, right? Heads has only 2 possible outcomes, and definitely so it's 1/2. And then we have E, where it's flipping a coin and having it land on its side, meaning it's not landing on heads or tails, but on its side. That is unlikely, right? Yes, remember, this is theoretical probability. Yes, it's probably can probably like with a very small percentage happen that a coin could land on its side, because I think I've seen a coin land on its side, but it's very unlikely, right? So that's why when we think of it, when we say theoretical probability, we think about those outlier things, right? And we think if we had a fair coin that is 50-50 exactly, 100%, there isn't any other probability other than if it lands, it cannot land on its side because there's only two possibles, right? So that's a very good way of thinking of theoretical probability and the difference of um, relative probability. So here's just a small question where you need to be able to convert from decimals, percentages, and also fractions. So I'm not going to really talk about this one, but I'm going to move on to the next question. And here again, here you're moving from percentages to fractions, still the same procedure, and it's actually very straightforward. But here's what I wanted to get to, right? Which talks about relative frequency. So you are given a coin with heads on one side and tails on the other. And if you flip the coin, what is the probability? What is the probability it will land on its head? It's one over two, right? And what is this probability that it will land on tails? It's 1/2 as well, right? But now, see, it says using a coin on your own, flip it 10 times and write down what it lands on. Now, for me, I flipped my own coin 10 times and I actually found that it landed with 5 heads and 5 tails, right? You could also do it the same and you'd actually find that maybe you'd find different answers. Therefore, our answers should be different for the rest of the two answers, which is the second one and the number 2 and number 3. So what is the relative frequency according to the coin? It's 5/10. Um, and also, does these results match the theoretical probability? In this case, yes, in my case, because when I threw it, it gave me 5 heads and 5 tails. So try that out, and that is the relative frequency. Whenever you see an experiment and you're actually looking at those numbers, and that would be a relative frequency, which is a probability. However, it's not like the theoretical probability as I explained previously. So other than that, I really hope that these videos are helpful. I really hope that I'll see you next time. So thank you for watching this video, and I'll see you next time.